Hey guys, this looks like a fun one. It says this dodecagon is regular, and it wants us to find the total shaded area, the area of these two trapezoids. This is day 27 of the 2025 Advent calendar. And if you want to try this one, pause it right now because I'm going to solve it in 3, 2, 1. First, let's focus on this top trapezoid, and let's draw this line perpendicular to the base. Let's call base 1 of the trapezoid X. Let's call the height Y, and we can label the second base Z. These are the notes for the area of a trapezoid. The area is equal to the height divided by 2 times the sum of the bases added together. And this will be the formula for this trapezoid. It'll be the height Y divided by 2 times the sum of these two bases added together. X plus Z. And this trapezoid is congruent to this trapezoid, so we can smush all this together and multiply it by 2. And to simplify this 2 and this 2 can cancel each other out. So we end up with the total shaded area is equal to Y times the quantity X plus Z. This looks important. Let's put a box around it and let's move it down here. So now we got to try to solve for X, Y, and Z. And then we'll basically have the answer to the question. Next, I want to find the measure of one of the interior angles of this regular dodecagon. And here's the notes for the interior angles of a regular polygon. Each angle is equal to 180 minus 360 divided by the number of sides. So in this case, it'll be 180 minus 360 divided by 12. 360 divided by 12 is equal to 30. So that means this is equal to 150 degrees. And that'll be true for all of these angles. They're all going to equal 150 degrees. Next, let's focus on this diagonal. The diagonals of regular polygons with an even number of sides always bisect these interior angles. So this 150 can split into 75 and 75. Let's clean things up a little bit and let's focus on this triangle right here. The one made up of the blue angle and these two orange angles. Since this is a regular dodecagon, that means each of these sides are congruent. So this is going to be an isosceles triangle. So the two orange angles are going to be congruent to each other. They'll each be 15 degrees. Because we need the sum of the interior angles of this triangle to be 180. And then let's draw this height of this trapezoid. It'll be perpendicular to this base. So this will end up being 90 degrees. And now we have enough information to find this angle here. Let's call it W degrees. Since all three of these make up an interior angle of this regular dodecagon, they all have to add up to 150 degrees. And this is 90, this is 15. That ends up leaving 45 for this angle here. And then if we end up drawing this right triangle, these three angles have to add up to 180 degrees, which means this third angle will also be 45 degrees. And now we can find this angle right here. Since the whole thing is equal to 75 degrees and this is 45 degrees, this remaining portion is going to be 30 degrees. And we just did all of this work to get this angle right here. Let's clean things up a little bit and let's draw this right triangle with this diagonal as the hypotenuse. Since this angle is 30, this angle up here is going to equal 60 degrees. So this is a 30, 60, 90 triangle. In every single 30, 60, 90 triangle, the side opposite the 30 degrees is always half of the hypotenuse. So this side is going to be half of the 12, which is equal to 6. And then the side opposite the 60 is always square root of 3 times the shortest side. So this side is going to be equal to 6 root 3. And this 6 root 3 is the same distance as our x, so we can label this as 6 root 3. And then we also know the z. Z is the distance between two vertices, two sides apart. So this is equal to z, and this is also equal to z. And that means both this is equal to 6 and z is equal to 6. So we can label this z 6. And now that we know the value of x, I don't think we need this anymore. And then this 45, 45, 90 triangle is the same thing as this triangle right here. So this is also a 45, 45, 90 triangle. And in every 45, 45, 90 triangle, the two legs are congruent. So this will also equal y. Does that make sense, y? And same thing's going to happen on this side. This will also be a 45, 45, 90 triangle, which means this is y and this is y. And the remaining portion of this is equal to 6. It's a rectangle of sides y by 6. And now we have everything we need to solve for y. This side is the same length as this side, so we know that y plus 6 plus y is equal to 6 root 3. And then from here, let's combine like terms, and y plus y is equal to 2y. We can subtract 6 from both sides, and that'll give us 2y is equal to 6 root 3 minus 6. Next, we can divide both sides by 2, and we end up with y is equal to 3 root 3 minus 3. And this is the answer for y. Now we have everything we need to find the area. Let's break it out of the box and give ourselves some room. In the place of the y, we can plug in 3 root 3 minus 3. In the place of the z, we can plug in 6. In the place of the x, we can plug in 6 root 3. And then we can multiply this out. It'll be 18 root 3 plus 18 times 3 minus 18 minus 18 root 3. And then we can combine like terms. The 18 root 3 and the negative 18 root 3 will cancel each other out. And 18 times 3 is equal to 54. 54 minus 18 is equal to 36. And that is the answer to our question. Let's give it a label of square units and put a box around it. In this regular dodecagon with a diagonal equal to 12, this total shaded area is equal to 36 square units. How exciting.